Sigma is really unrealistic. Most of the time you don't know the sigma. And jumping ahead to Wednesday's lecture, what's a good substitute for sigma? I mean, obviously, if you know the sigma, like in a spinner assignment, it's 2.87. But for most real-life examples, you really can't get the sigma. So what's a good practical substitute for it? The standard deviation of the population is estimated by the standard deviation of the, starts with an S, of the sample, which is called the S, the letter S. Okay? So sometimes you plug in the S into this formula when you don't know the sigma. This S is available. Just like you can get 100 numbers to calculate the average, you could also calculate the S of the 100 numbers. But we're not going to do that right now. We'll do that on Wednesday. Right now we're going to make believe, which is unrealistic, that we know the sigma. Okay, so saying the answer is 20.5, I believe the average is 20.5, is really not accurate. It's not correct, because if you took another 100 numbers, you get a different answer. So you really can't bet your life on the statement the average is truly 20.5. If you want to be a little bit more sophisticated about it, you would tell the person who hired you the answer is somewhere between 20 and 21. Now you have a much better chance of being right. Instead of having a point estimate, which was the original, now we have an interval estimate. And in fact, the question we're going to basically, well, I'll point out the question in a second, which we come up, so we believe the average age is somewhere between 20 and 21. Now the person who hired you realize will get very frustrated. He or she, in this case Father Harrington, wants a simple answer. Say, I gave you money, what is the average age on campus? You come back and you tell him, I can't give you a single answer because that answer will be wrong. I can tell you it's somewhere between 20 and 21. So after he calms down, because he has a temper, Father Harrington, he'll say, okay, fine, the answer is somewhere between 20 and 21. Are you guaranteed the answer between 20 and 21? Can you guarantee that answer? Is it possible that just because of bad luck, the average is really 19.9, and you just took a sample and it came out to a little bit higher than 19.9? Is that possible? Yeah, so you can't guarantee that the answer is between. What can you say? So the guy say, I can't even guarantee it. So what do you think he's going to ask you next? If you were working for somebody and you gave him an answer, and you say, I'm not really 100% sure it's the right answer, what's the next logical question? Who's saying that? Yeah, how sure are you? Are you 95% sure? I mean, you can't be 100%, are you not? Because if you're 95% sure, I can now go to the board of directors and tell them the average age on campus is somewhere between. But if you're only 35% sure, I'm not going to go to the board of directors, whoever asked me to do this project, and say, so the question is, the question we're going to try to find in this, so we try to find a pair of numbers so that you're 95% sure. Why 95% sure? It's a high number, but you can never expect to be, as we'll see later on, 100% sure. So the typical example, in fact, every example in chapter 11 starts out like this. Find a 95% confidence, it's called a confidence interval estimate of mu. Mu is the average of the population that we're trying to find. And the answer to the question after all the calculations are done will be a simple pair of numbers. And I'm saying 95% sure the right answer is between here and here. That's the essence of the problem. So every problem, now what can change from example to example is the size of the sample, the size of the average, the sigma might change, or the percentage of confidence might change. It can be sometimes you want to be 90% or 80% or 99%, but the basic structure stays the same. So but instead of showing you a formula, I want the class to tell me the formula. Now again, if you had this once before and you dropped it, or if you had this in high school, or you read the book, please don't answer the question. I'm only asking the people who've never seen this before in their lives to tell me what the formula, sorry again, changing the tape.